Welcome to the 12th video in my FPS character controller tutorial series playlist, and in this video we're going to be talking about preventing weapon clipping using a shader. There's a couple different ways to do this, but basically when you walk into things like walls and stuff, you don't want your weapon to get hidden and clipped into them. You can put your weapon on a separate layer basically and like draw it over top it using a viewport, but we're going to be showing the shader method in this video. I'm going to show a couple different levels of detail here in terms of how you can do this. First off, I just created this pre-made function, apply clip and FOV shader to view model. I'll post this in the description so you can copy paste into your project, but basically you just paste in or pass in the weapon view model spawned into your scene, like your node 3D, and then you can optionally pass in an FOV for your view model to modify the FOV, or you can just leave it as -1 to like not change the FOV from the default camera one. And then what this function does is it just replaces all of the materials in your view model with this shader material I made, which has the view z clip fix in there, and it's just like copying over all of the code for the materials that are all of the like properties of the materials from your original weapon view model materials to this new shader clip fix material that puts on all your meshes in your gun. And the only thing hopefully you should have to change is this line right here. So the weapon clip and FOV shader, and you need to make sure, I'm going to also include this file in the description, weapon clip and FOV shader.gd shader, and then you need to make sure this is pointing to the same location in your project as you've copied into in the file too. And yeah, with that, in my case this just works. I'm also going to show how to create this. If you want to like make your own, or for some reason this doesn't work for you, I'll show you how this works. But I'll include this function, which just blanket adds it to all your models, and this like standard weapon clip and FOV shader GD shader. And yeah, you just got to call this like whenever you equip your weapon onto the spawned in view model. Now, if this doesn't work for you, if your weapons materials are weird for some reason, or if you just want to learn how to do this yourself, I will show you how to create a clip shader onto a weapon. So I've made a knife here for my character controller. I'm just put it under my camera, basically under the view model node for my character controller, and obviously it's clipping into the walls and stuff. So let's get a view model Z clip prevention shader going. So I'm going to click make local on my model, and that will expose all the meshes. And luckily this one only has one mesh. If it has multiple meshes, you need to do this for every single mesh. That's why I made that script, which automatically swaps the shader for all meshes. And then you might have to click make unique on your mesh and go into surfaces. And then in your surfaces you should see like a material for all the textures of your model, and hopefully it's a standard model, standard material 3D. And on the standard material 3D you can right click, convert it to shader material, and then you can click into your shader, and then if you go into the vertex shader, now this is all the code that Godot is like doing for you automatically in the standard material, but now we have access to edit the actual code of this knife. So I'm just going to actually copy in the code from the weapon and clip FOV shader. So in the vertex shader, this is where we're interested in modifying all this. I'm going to first add this line, so position, and this is the output position of the vertex. So like the vertex starts in model space, so like in Blender all the vertices are relative to the center of the Blender scene. So we're going to take the vertex.xyz, pop a 0 and make it a vector, or pop a 1.0 in the W component of the vector 4. This is necessary for matrix multiplication, and multiply it by the model view matrix. Now it's relative to the camera. and then you multiply it by the projection matrix. And then, so if you're using Godot 4.3 or 4.2, it actually just changed. So the script that I provided in the description, it's updated for Godot 4.3, and essentially what you do is squish the Z position of the vertex towards position.w. And this used to be squishing it towards position.00 would work, but this doesn't work anymore. That would make it behind everything. The reason for this is that Godot recently flipped the Z buffer, and they did this because like it's apparently better for like performance or something, or like it's better for like Z fighting. It has some like precision benefits for like the Z buffer somehow. So they recently flipped it, so instead of going towards 0 is close to the camera, now 1 is close to the camera. It's flipped. So yeah, if you're on Godot 4.2 or below, this should be 1. If you're on Godot 4.3 or above, this needs to be position.w. And I said this was like the Z buffer is 1. And the reason we're mixing it towards position.w, I guess I'll show you. I have a little diagram here. But essentially, and maybe I'll ramble about this a little bit after I get the basic vertex shader set up. So we're in model space, that's the blender or whatever you imported it from, local to the model, multiply it by the model matrix, then model matrix, then it's in world space, then you multiply it by the view matrix, then it's in view or camera space, which means the vertex would now be relative to the camera rather than the center of the model. And then you multiply it by the projection matrix, which puts it in puts it in clip space. And then this is right before it goes to the fragment shader, but right in between the fragment shader, like right before it gets to the fragment shader, we need to put it in something called normalized device coordinates. And what you do is actually take the clip space XYZW, and then you divide the XYZ by the fourth component W, which I think is actually like the Z component of the view space vertex saved. And because we divide it by W, which is the old Z, if you mix it towards W, W divided by W is 1. So this will be the equivalent of mixing it towards 1, which is the 1 is the near clip position of the new Z buffer set up in Godot. So by doing this, position.z mixed towards position.w, then now we have this clip shader, which prevents our weapons from clipping into the wall. And now for the sometimes you want to modify the FOV of the gun, like a lot of games might do that, I think. And this is what the projection matrix looks like, basically. You don't have to understand this to do this, but only point I'm making right now is that if you see in the top, this is basically like a 2D array, essentially. And in the 0, 0 spot, you see it's 1 over aspect multiplied by tan of FOV over 2, and this is 1 over tan of FOV over 2. So the FOV is basically handled by the first 2 spots here. So this one's 0, 0, and this one's 1, 1, and we have to modify these to modify the FOV of the gun. Yeah, so what I did in mine, I just created this view model FOV uniform float. So you can pass in the view model FOV parameter to the shader, and you can adjust that on the shader parameters just like any other shader parameter in Godot. So I'll add a uniform float view model FOV, and then what I did on mine is like I only had it change the view model FOV if we passed in one that was over 0. So like I could just pass in -1 if I didn't want the FOV to be modified. And then, yeah, this code right here to modify the projection matrix. And this, I mean, I would really just recommend copying this from the description. This is, what's happening here is this is converting it into radians, and then the 0.5 times is converting into the FOV over 2, which you saw as a component of the projection matrix, and then the 1 over part. And then we're calculating the aspect ratio, viewport size, X to Y, just like the aspect ratio of your screen. And then boom, we're modifying the 1,1 position and the 0,0 position of the projection matrix with the 1 tan over FOV thing. So then you could do something like, actually I should be able to see it in Godot even. If I want, now I can modify the FOV of this knife on the fly here, and looks pretty messed up, but yeah, essentially we can modify the FOV, and it's now in front of everything. I don't have anything on this scene, but here we set the knife's view model to 54 FOV. Yeah, it looks a little bit different. It was fully on screen before, and it's still not clipping. So that is the basic gist of it. If you need to create your own, you'd be adding this portion of code into the vertex shader. And for Godot 4.3, you mix it towards W, and 4.2 and below, you mix it towards 0.0. The reason for this is because they recently flipped the Z buffer. And really, that's all you should need to know. And hopefully the like script that I gave you should work for most people. Oh yeah, and then one more thing to mention is that I mix mine towards, the reason you would maybe not want to mix it towards 0.999, which is like as close as you can get, or like 99999 or whatever. I noticed like more artifacts if I did 999 versus just like 0.9, which I found 0.9 in practice to be like, so this is the factor you squish the Z position towards the near buffer. And if you squish it too much, I noticed my model was like starting to have some artifacts. And basically that is why I just do 0.9 over 0.999. And yeah, that should be pretty much everything you need to know to get your weapons to stop clipping. Your view model weapons, you have to basically put it in the vertex shader and squish the weapon. What we're doing is essentially just squishing the weapon towards the screen as close as possible, and basically just putting it in front of everything else to like an extreme degree, so that there's not going to be any clipping when you're like running right up against the wall. And I also wanted to like ramble a little bit about everything that's going on here, because I think it would be like useful to just give kind of like a cheat sheet or overview of everything that's going on in this shader, and like just like an overview of shaders in general in Godot, because it's like I feel like it's not super well documented. So I guess I'll just give like an overview of the vertex and fragment shader pipeline. So obviously, like with the vertex shader, that's called every vertex, and then fragment shader is called every pixel on every triangle that's rendering. So you start with the vertex, then it goes to the fragment shader. So you can modify the position of every single vertex. That's what the position built-in is for. And that's what we're doing here. So we're like squishing the Z position towards W. And when you, so the vertex built-in, when you first get it in the vertex shader, that's going to be in model space. So essentially it starts in model or local space, which is like, that's when you create your model in Blender or whatever you made it in. Everything's relative to like the origin point of the Blender scene. And then when you multiply it by the model matrix in Godot, actually we got the model and view matrix combined, but you can do both individually too. There's a model matrix constant in Godot here. Then after you multiply it by the model matrix, you're in world space relative to the center of the Godot world. So like all your Blender or whatever models are centered or relative to the center of the Godot scene. Then you multiply it by the view matrix, and then that makes like the camera as the origin point. So everything is going to be relative to the camera, and this is important because we're about to go into the like perspective transform or the projection matrix of the camera, and start getting to the point where we can draw it on screen. Yeah, so what we're doing here is modifying it by the multiplying it by the projection matrix, which we actually modify to put the FOV in here. And after you multiply it by the projection matrix, it's in something called clip space. And basically the point of clip space is to like clip anything outside of the near or far planes of the camera. So like if you have like an object out here, like further than the camera can see, it's supposed to be a box, then it would clip it out. You wouldn't be able to see it. And also the same thing can happen if things are like too close to your camera or just like behind your camera, then they won't draw. Yeah, the reason, so Godot just swapped the Z order, right? And so the reason we have to mix it towards position.w instead of 0.0 is because 1 is now the near point. But when we put it in clip space, before we can like squish it into the range of the camera it's supposed to see, we have to do something called perspective division. So you do essentially the calculation here would be clip.xyz divided by clip.w, and then it's an NDC, which would be every vertex is between the values of 1 and -1 on x, y, and z, and anything outside of that range just gets clipped out, and you're not going to see it on your camera in Godot. So if things are too far or too close, or if they're like outside of the view frustum, the range of view of the camera, frustum is like this weird kind of squished box thing. But essentially, like you got this blue is like the FOV of the camera. So you take like the angle here and squish everything into this box that kind of shoots out in this triangle shape of the camera. And then you clip it off at these two endpoints for the near and far clip plane of the camera. And yeah, I'm just kind of rambling here. I don't have a clear thing that I'm trying to show you here, I guess, but I feel like it might be helpful if I just ramble to some people. And you might be confused about like, what is this like, so you've seen the projection matrix, what is this like FOV over like 2? Why is it not just regular FOV? And what's the tan? So tan, SOHCAH TOA. Tan is TOA, which is opposite over adjacent. So this portion right here is half of FOV between these two angle points here. So we're taking like this half triangle kind of thing in the camera's FOV, and if we take the tan of the FOV, that will give us the so if we have like the adjacent of the triangle, and this would actually just be the far clip plane minus distance minus the near clip plane distance, that would be the adjacent. So then basically you'll be able to calculate the like size of the far end of the view frustum based on taking the tan of half the FOV here. So that's basically the general idea as I understand it. That's why it's like tan over FOV divided by 2. And then also you multiply by the aspect ratio, because otherwise it would be like squished. Like if you had like a screen that's not perfectly 1-to-1 aspect ratio, which nobody does, it's like 1920 by 1080, you multiply the FOV calculation by that to account for like super wide screens. And that's basically the general idea there. That's as much as I'll go into because I don't fully understand it myself. I understand like the general idea, but I haven't fully gone into the projection matrix. I've been meaning to, but I don't fully understand. But that's the general idea. So after the projection matrix, the idea is to squeeze it into this view frustum by multiplying by that matrix. But actually, it's not all the vertices are going to be within this until this perspective division part. And essentially, if I recall correctly, this -1 in the projection matrix, it like saves the original Z position. And then it will divide it, so this W becomes the original Z position because of this -1 here, if I recall correctly. But essentially, it's only in this cube, square, frustum thing after the perspective division. And so this really close to the camera in Godot, this is 1. And then you have to mix it towards 1. And in a lot of game engines, this would be -1 NDC, and this would be +1. But in Godot, it's 1, and then the far is -1 because it's flipped because of that update they did. So you mix it towards position.w of the clip space, which is essentially going to result in mixing it towards position 1 on the Z. And then this perspective division happens, and then it's going to be squished into this view frustum with all of your vertices squished towards the near plane of the camera. And then finally, once it gets into the fragment shader, everything is pretty much in normalized device coordinates there, which is all going to be between 1 and -1. So everything in the fragment shader pretty much is in normalized device coordinates, or a lot of the stuff is. And so you could also do like if you didn't modify the position of the vertex shader, you could do the same thing in the fragment shader, or a very similar thing. You can grab the clip space. So by default, the what is it? The vertex built in and the fragment shader, it gets passed in. It's really confusing because there's all these different spaces you're hopping in between, but the vertex by default is in view space. So to get it in NDC space, you have to multiply it by the, so it's in view space, multiply it by the projection matrix. And maybe I'll link this like image in the description as like a cheat sheet for people. I'm probably going to look back at it because it's hard to remember all these things. Yeah, so the vertex built in is going to be in view space. So you multiply it by the projection matrix, and then we have what's called clip space, and then NDC. If you divide it by W, divide clip space.xyz by clip space.w, then boom, we're in NDC space. And then actually, I think I just made a mistake here. So if you do NDC +1 divided by 2, then this would be, so depth goes between 0 and 1. So it's kind of confusing because I think depth is actually like a texture. So you can't have like a negative value in a texture. It has to be between 0 and like 255 or whatever it is. So to put NDC, which is between 1 and -1, between 0 and 1, you have to do, so add 1, so everything's above 0, and divide by 2, so it's between 0 and 1 again. And then I'm going to mix it towards 1.0, which is the near clip plane of Godot. And then that should accomplish the same result. Yep, accomplishes the same result as the code up here. But what I noticed with setting the depth in the fragment was that like I get these weird like artifacts around the edges. I don't know if it shows up on OBS, but like there's like weird lighting artifacts when I was setting like the depth in the fragment shader instead of the vertex shader. So you can do this. You can go calculate the normalized device coordinates using the vertex and the fragment shader instead. But I found it worked better on the vertex shader. And yeah, the 0.9 rather than 0.999, I also was noticing some artifacts. So I found the position.z mixed towards W by 0.9 to work the best. And yeah, I think that's pretty much everything. You just have to remember this whole like big chain of events that's happening. This goes to this, this goes to this, this goes to this. Then we're in clip space. Between the fragment shader, it does this sneaky perspective division before everything's handled in the fragment shader. And then, yeah, you got to mix towards 1 in 4.3 and 0, 4.2 and below. And I think that's pretty much everything I wanted to talk about. I didn't have a clear picture of this like chain of transformations until recently, but it is a very useful thing to know if you're working in shaders, because yeah, you're basically just hopping up and down between all of these different spaces like all the time. Like I was doing ray marching shaders recently in the fragment shader, and you have to do all sorts of hopping up and down between like view, and it's because I didn't even do the projection matrix code. Okay, we're good. Yeah, and I think that's pretty much everything I wanted to go over for the tutorial. I'll put that like cheat sheet thing probably in the description. But yeah, it gets confusing like hopping in between like all of the different transform spaces. I was doing ray marching shaders recently, and like you just have to like hop all up and down between those different spaces in the vertex and fragment shaders and whatnot. And it's very useful to know. You're kind of going in blind if you don't understand that whole kind of sequence of transformations. You don't have to understand like everything 100%, but at least understanding like what the different spaces are and the order they go in. You don't necessarily have to fully understand the matrix multiplications, but this is the order they go in. And often in shaders you have to like hop up and down between them and understand the normalized device coordinates and whatnot, and understand all the different conversions that happen from the model space all the way to screen space. So yeah, I think that's pretty much the video. Hopefully this helps somebody. I hope you enjoyed, and stay tuned for the rest of the videos in this FPS tutorial series. I'll be putting out some more soon, but I just wanted to put out this view model shader one and explain a bit about everything here. Thank you for watching.